So in this video, I'm going to complete the integral which I started in the last video. So this was basically our integral 1 over 2 times integral of 4t minus 4 over square root of 2t square minus 4t minus 7 and plus integral of 2 over square root of t to 2t square minus 4t minus 7, and we were integrating both of these expressions with respect to t. So this is the integral we evaluated in the last video. So today we are going to evaluate this integral so that we can put the values of both of these integrals in this expression and can get the final answer. So this is the integral I am talking about. 2 over square root of 2t square minus 4t minus 7, and we are integrating this with respect to t. So this 2 can be moved outside the integral, so I am moving this outside the integral. So this becomes the integral of 1 over square root of 2t square minus 4t minus 7, and we can see that in the numerator we have a quadratic expression, but this quadratic expression isn't factorizable. So and even if this was factorizable, it would be of no help to us because we couldn't have used the partial fraction resolution because there's a square root over this expression. So we need to think of some other strategy, and the strategy which can be used here is basically completing the square. So we need to make this first term a perfect square. We need to think of a term whose square is 2t square. So t square is simply t square. So t square, thinking of a number or thinking of a think of an expression which whose square is t square is not that difficult. T is that number, and the issue lies with 2. We need to think of a number which has the square equal to 2, and that number is basically square root of 2. When we take the square of square root 2, square and square root cancel out and we are left with 2, and we want to complete the square, so this needs to be written in the form of square. So we'll write square root 2 times t whole square. So this gives us basically that same 2t square because the square distributes on both of these square root 2 and t. So square root 2 whole square is basically 2 and t square is t square. So we get 2t square. So we have the a square term now. Second term which involves t, we can make this we can use this term for 2ab term. So the formula has minus 2ab in it. So minus 2 a, we have already decided what is our a, so that is square root 2 into t, and we need to think of some b which then when multiplied with 2 and this a gives us 4t. So that is square root 2 because square root 2 and square root 2 when multiplied give us square root 2 whole square, and square root cancel out, so we get 2, and when we multiply this 2 with that 2 we get 4t. So minus 4t. So now we have a square minus 2ab. So the formula, we want to complete the square here, so from the third term of the formula is plus b square. So plus, we let b square root 2, so square root 2 whole square, and these two terms, they basically are equal to these two terms here. This gives us this and this gives us this, but this square root 2 whole square is not equal to minus 7. So we need to come up with some term which when solved with this square root 2 whole square gives us minus 7. So that term is basically minus 9. Square root 2 whole square is simply 2. Square and square root cancel out. Minus 9. So 2 minus 9 is minus 7. So that's why I have written minus 9 here. So the integral becomes 2 times the integral of 1 over square root of the first three terms make a minus b whole square. So a was square root 2t minus b was square root 2. So square root 2t minus square root 2 whole square minus there was 9 here. So 9 can be written as 3 squared. So we have this form of integral now, and what we can see is that this kind of resembles 1 over x square minus a square, and x square minus a square, basically, if you think of it, the derivative of secant inverse of x and cosecant inverse of x basically have a denominator in them which has one x square minus 1 in their denominator. Their denominator has x square minus 1 in them. Here we don't have 1, we have 3 squared, and here we don't have x, we have square root 2t minus square root 2 whole square. So in place of x we have this thing, and in place of 1 we have this 3. So we want to use basically the identity, and that identity is secant square theta minus 1, but in the denominator. But firstly we need to use trigonometric substitution, and this x square minus a square thing gives us the hint that we can either use um, secant for our trigonometric substitution, or we can use cosecant. Secant is suitable here because I guess there is a negative sign in cosecant, the derivative of cosecant inverse. So this basically resembles secant inverse, the derivative of secant inverse. So we are letting using trigonometric substitution involving secant. So I was saying that we will use this identity 1 plus tan square theta is equal to secant square theta, and we want to make secant square theta minus 1 in the denominator, so we can replace it with tan square theta. So if we want to make this thing secant square theta minus 1, we need to make this thing 1, and we also need to make sure that we get secant square theta out of this term. So I'm going to call this thing written inside the square equal to 3 secant theta. Why 3 secant theta? Why not secant theta? Because we want 1 here, and for that we need to take 3 square common, and we can't take 3 square common from one term. We need 3 square here as well. So that's why we will call this thing equal to 3 secant theta, so that 3 gets squared and we can take 3 square common from both terms. So I'm calling this square root 2 t minus square root 2 equal to 3 secant theta, and I'm taking the derivative of this equation with respect to theta. So the first term is square root 2t, square root 2 will remain as it is, and we are taking the derivative with respect to t, so this will become dt over d theta, minus we are taking the derivative of this constant with respect to theta, and the derivative of constant is simply 0. On the right hand side, this 3 will remain as it is, and we'll take the derivative of secant theta with respect to theta, which is simply secant theta tan theta. We are trying to evaluate the value of dt here because we need the value of dt in terms of theta to evaluate this integral. So we want this dt term separate. So square root 2 dt over d theta, 0 has no value, so equal to 3 secant theta tan theta, and we want dt, value of dt, so we need to move this square root 2 to the other side. This is being multiplied on this side, on the other side it will be divided. Firstly I basically moved d theta to the other side. D theta was being divided, so it is multiplied on the other side. This becomes 3 secant theta tan theta d theta, and this square root 2 is divided, so this becomes dt is equal to 3 secant theta tan theta d theta over square root 2. So now we have the value of this thing in terms of theta and the value of this thing in terms of theta. So we can simply plug in those values to find the integral. So this becomes 2 times the integral of 1 over square root of 3 secant theta whole square minus 3 squared into the value of dt. So this entire thing is the value of dt. So just put in that value. So 2 times the integral of 1 over, I have separated this 3 squared so that we can take it common from both the terms. So this becomes 3 squared times secant square theta minus 3 squared, and this thing is the same. In the next step, 1 over 3 square is taken common and there is a square root over the entire thing, so that square root can also be separated. So 3 square under the square root into secant square theta minus 1 under the square root. So square and square root cancel out, and this 3 and 3 also cancel out. So now we have achieved our goal. We have secant square theta minus 1 in the square root of secant square theta minus 1 in the denominator, and secant square theta minus 1 is simply tan square theta. So we'll write tan square theta in place of it. Square and square root cancel out. So we are left with 1 over tan theta into secant theta tan theta over square root 2, and tan theta also cancel out. So we are left with 2 times the integral of secant theta over square root 2, and we are integrating this with respect to theta. So this becomes 2 times the integral of 1 over square root 2 secant theta d theta. This square root 2 is a constant, it can be moved outside. So 2 over square root 2 times the integral of secant theta, and we are integrating this with respect to theta. Square root 2 can be written as square root 2 times square root 2, and these two square root 2's cancel out, and we are left with a single square root 2, and this is written here outside, and we need to now integrate secant theta with respect to theta. So this can be integrated, secant theta can be integrated by multiplying secant theta with secant theta plus tan theta, and also dividing by secant theta plus tan theta. So when secant theta is multiplied with this expression, this becomes secant square theta plus secant theta tan theta over secant theta plus tan theta. So this step basically helps in integrating secant theta, because now we have the derivative of the denominator written in the numerator. The derivative of secant theta is secant theta tan theta, and the derivative of tan theta is secant square theta. So whenever this is the case, that the derivative of the denominator is written in the numerator, it simply has the antiderivative equal to natural log of, or any log, it doesn't matter what the base is, just log. So I've used the base e here, so I've written natural log. So natural log of absolute of the denominator is our antiderivative, so natural log of absolute of secant theta plus tan theta. So we have the value for the second integral as well. We just now need to put the values in the in our solution. So the whole solution becomes 1 over 2 times 2t square minus 4t minus 7 under square root. 1 by 2 is basically square root, plus square root 2 plus the value of this square root 2 natural log of absolute of secant theta plus tan theta. And when 1 by 2 gets multiplied with these two terms, we are left with 2t square minus 4t minus 7 raised to power 1 by 2 plus 1 over square root 2 natural log of secant theta plus tan theta. This is not our final solution, because this has an expression involving t, and this has an expression involving secant theta plus involving theta basically. So our original expression question wasn't in terms of t or theta, it was in terms of x. So we need to replace the values of these expressions in terms of x. So firstly I will make this whole expression in terms of t. So I'll convert these thetas in form of t. So secant theta can be found easily. 3 secant theta was equal to square root 2 t minus square root 2, and we have secant theta can be easily found, so 3 can be moved to the left side, so we are left with square root 2t minus square root 2 over 3. So secant theta has this value. We can just plug in the value of secant theta here, and we also need the value of tan theta. So using the identity which I mentioned a few moments ago, we can also find the value of tan theta. So 1 plus tan square theta is equal to secant square theta. So tan square theta is equal to secant square theta minus 1. And we need the value of tan theta. So we need to take the square root of both sides of this equation. So tan theta is equal to square root of secant square theta minus 1. So we need to find the value of secant square theta, and we have the value for secant theta, which was square root 2t minus square root 2 over 3. So we are squaring both sides. So in the denominator we had 3, so its square is simply 9, and in the numerator it will be a square plus b square minus 2ab. So square root 2t square plus square root 2 square minus 2 times square root 2 times square root 2 into t. So in the numerator we get 2t square plus 2 minus 4t over 9. So tan theta, when we plug this value of secant square theta in tan theta, we get square root of 2t square minus 4t plus 2 over 9 minus 1. And when we take the LCM, we get 2t square minus 4t plus 2 minus 9 over 9. So the square root of 9 is simply 3, and the square root of denominator remains as it is. This is not a perfect square, so the square root remains as it is, 2t square minus 4t minus 7. And the first term in our final solution was in terms of t, so I am just converting the second term in terms of t. So the second term becomes 1 over square root 2 natural log of secant theta, which is square root 2t minus square root 2 over 3, plus tan theta, which is square root 2t square minus 4t minus 7 over 3. We can take the LCM here. So I've taken the LCM. The denominators are same, so the LCM will be same. So it is 3, and the numerators are added. So square root 2t minus square root 2 plus square root of 2t square minus 4t minus 7. So this whole expression is in terms of t now, and we need to use our initial substitution, which was t is equal to e raised to power x, and t square was equal to e raised to power 2x, to simply convert this final solution in terms of x. So this becomes square root of 2 into e raised to power 2x minus 4ex minus 7 plus 1 over square root 2 times natural log of absolute of square root 2 ex minus square root 2 plus square root of 2 into e raised to power 2x minus 4 into e raised to power x minus 7 over 3. And we also need to add the constant of integration, so plus c. So this is basically the final solution for this problem.